Now coming to the non-weighted codes. Okay, so codes which don't have any weights. Weights means their LSB positions is not saying any. Their LSB positions are not saying. Their MSB position is not saying anything. Like they don't have weights. Based on that, we cannot derive their equivalent decimal or binary number. Okay. So you can see a digit. So gray code is a non-weighted code. So you can say that gray code is not a number system. It is an alternative way to represent 4-bit data. So it's not a number system like you are having binary, right? Binary is 000. So one more way to represent a binary number in form of gray is this. Okay. So that is what they are trying to say. This is not a number system. This is an alternate way to represent a 4-bit data. So once one bit changes from one decimal digit to next, so this means that when you are going from 000 to 001, so one bit is changing. Now if you are going from 001 to 0010, during that time 2 bits are changing. You see, now the LSB is changed from 1 to 0 and the next LSB is changed from 0 to 1, so 2 bits are changing. But if you see the example of a gray code, so during that time only 1 bit is changing, that is second LSB, that is changed from 0 to 1. So that is the difference between binary and gray. In gray code only 1 bit is changing. So useful for reducing the error in communications and can be scaled to larger number. So what they are trying to say from this useful for reducing errors in the communication means they are trying to say this thing is like suppose you are dealing with some two multi domains. Okay, so when you want to pass and control information, suppose you want to compare the result of one control information with another clock domain control information. So in that case you should establish a secure communications, means transmission should be less error prone. So during that time you will go with the gray codes. So when you're using gray codes, in that time only 1 bit can change. So during that time you can easily synchronize your circuit, and if 2 bits are changing, you can easily find that bug, means you can say that this is wrong information that is coming. So debugging is easy. So this is the application of gray code. Whenever you are you want to compare a control information from one clocking domain to another clocking domain, during that time you go with the gray codes that are much more secure. Coming to ASCII code. So ASCII means American Standard Code for Information Interchange. So ASCII is a 7-bit code frequently used with the 8-bit for error detection. Okay, so you know that ASCII codes are only 8-bit number, and basically they used for error detection. So like character A, ASCII is 10001 41 in hex, decimal 65 and octal 101. So if you are writing a capital A, during that time this equivalent decimal number is 65. So similarly you can use these ASCII characters also. Now coming to the parity codes. So parity codes are formed by concatenating a parity bit P to each code word of C. So they are trying to say that parity codes parity code is just you calculate a parity on certain bit and just append that thing at the end of the code. Okay, so like you see, you want to pass this information, right? So before that you pass the parity information P. So one is added as a parity before they are transmitting the information. So this is one type of parity codes. So during that where the parity code is used, this is used in error detection mechanism. Because what is the problem? Suppose some bit is changing. Okay, so what you will do, first you have to calculate in transmitter side one parity. Okay, and you send that parity along with the information. Okay, after that your receiver part will take that parity and calculate its own parity based on the received data, and it will compare. Okay, so if parity matches means you are getting the right data. If parity mismatches means there is some problem in the communication and you cannot take data directly. That is what they are trying to say. In an odd parity code, the parity bit is specified so that the total number of ones is odd. So if total number of ones are odd, 3, then you can say that you add 1. So this is called as odd parity. If even parity means if the number of ones are even, here you see 1 1 1 1, so add 0. So this is called as odd parity. Add 1 means even parity. So this is what they are trying to say from parity codes. Now how to represent a signed number? For computer, desirable to represent everything as bits. So we know that our computer, whatever you